Greetings everyone, I have been getting asked how to do Kohya STXL Stable Diffusion XL training on a free Google Colab. Unfortunately, it is not possible to do this training on a free Google Colab because of the RAM limitation. However, we are going to use a free Kaggle account to do Stable Diffusion XL LoRa training fully. We are going to do training with both text encoder and UNet with 32 network rank dimension, which are extremely optimal settings, and we are going to obtain amazing quality images. You may be wondering why it is not working on a free Google Colab by working on a Kaggle account, because Kaggle is providing dual GPU as you are seeing right now for even free users. And it is amazing that they are providing 30 hours per week for free, 100% free. So Kaggle is the best alternative of Google Colab, and it is even better. In this tutorial, I will show you step-by-step setup and training of Kohya STXL on a free Kaggle account. Then I will show you how you can use those trained LoRa checkpoints on your computer. Hopefully, in another tutorial, I will show how you can use Automatic 11 Web UI on a free Kaggle account. So let's say you have a computer that you can run Automatic 11 Web UI, but you can't do Stable Diffusion XL training. You can do your training on a free Kaggle account. Then you can use your trained LoRa files on your computer. So this tutorial is the tutorial that you were looking for if you don't have a strong GPU. This tutorial is a little bit tricky, therefore please pay attention to every minute of the tutorial, and also join our Discord channel and ask me any questions, or reply to this video and ask any question. So I have prepared a very detailed GitHub README file. All of the instructions and links that you are going to need is shared here. If it be necessary, I will update this file in future, so this tutorial will be always up to date. Always check out this file when following this tutorial. The file link will be in the description of the video and also in the comment section of the video. We will begin with registering our Kaggle account, and you may be wondering what is Kaggle. Currently I am logged into my account. However, when I open this in a private window like this, you will see two options to register. Register with Google, register with email. You can register with Google, it is very easy. After registered and logged in your account, you have to verify your phone number to be able to use GPUs provided by the Kaggle. So go to settings link, and in here you will have your phone number verification option. You see my phone number is verified. It is also showing how much private datasets that you are using, how much GPU time that you can use more. This is really a good feature, because on Google Colab we don't see how much GPU time we have. On Kaggle it shows you how many hours you can use per week and how much you have used already. You see it shows each week you get a minimum 30 hours of GPU. It also provides TPU timing as well. So Kaggle is better than Google Colab if you ask me. Kaggle also have more options. When you type what is Kaggle to the Google, you can obtain more information. So to do Stable Diffusion XL training on Kaggle, you need to generate a notebook. Click create button here, select new notebook. It will load the notebook like this, and this is the notebook. The notebooks are similar in all of the platforms that you use. You can either use the commands that I have shared here, or you can download the notebook I have shared on my Patreon post. So when you open this Patreon post, just click this attachment and download it. Then click File, Import Notebook, Browse Files, select the downloaded notebook, import, and you will have everything necessary here. It is totally same. If you are not my Patreon supporter, you can use this code that I also shared on GitHub, or you can support me and download this notebook directly. There are some description here. You can pause the video and read it if you wish. So we are going to use Kohya GUI SS and we are going to use the latest version. This is really important. Why? Because in many other notebooks that you can use on free cloud services like Google Colab or Kaggle, they are all specific to certain commit. However, on my tutorial, we are going to use the latest version of the Kohya. Therefore, we are going to have all the optimization and bug fixes. I have spent huge time to figure it out how to make this work on Kaggle. Unfortunately, it doesn't work on Google Colab because Google Colab has very limited RAM. Actually, this Kaggle also has very limited RAM. However, since it gives us dual GPU, we are going to utilize it. So to begin with, we need to start our session. When you hover your mouse in the right section, you will see accelerator option. This is really important. You need to pick accelerator GPU T4 X2, which means that it will give us dual T4 GPU. Our language is Python. We are not choosing persistence, so everything will get deleted after we turn it off our session. So this is really important. Don't forget to select accelerator GPU T4. This option will not be available if you did not validate your phone number. So don't forget to verify your phone number before starting. Okay, to start the notebook, we click this icon. You see draft session starting and Jupyter is being waited. You see, I have already used 11.5 hours out of 30 hours of my GPU time. This is really good when compared to Google Colab. You know what you have, you know how much you can use. Alright, our session started. When you click here, it will show how much space you are using, how much CPU you are using, how much GPU you are using. This is really better than Google Colab. So this script will clone Kohya GUI SS into our runtime drive and it will install it. It is so simple. You see only 4 lines of script. You can also type this or you can copy it from the GitHub file I have shared here. So about Kaggle, the only thing that you need to know is the path. When I click here, you see it shows my Kaggle working directory. This is where our files will be saved during runtime. Only during runtime. So when we terminate our session by clicking here, they will get all deleted. So Kaggle working is our path, our root directory. You see it has cloned it into here. Now it is installing all of the necessary packages. Just patiently wait until this operation is 100% completed. And this is the commit that I am using right now. You can also switch to this commit by making this like this. However, I don't suggest you to git checkout unless you get error. You can also reply to this video and hopefully I will make the fixes. I will make the updates in GitHub and also in the Patreon post for you. So meanwhile this is getting installed, let me tell you several other things. If you haven't watched my previous tutorials about Kohya STXL LoRa training, I suggest you to watch them. This LoRa training video is a masterpiece. It explains how LoRa training works. Fundamentally, this very comprehensive LoRa training video will show you every detail about LoRa training on STXL. This is my Rampot LoRa training video. Why I also share this? Because in this video I have shown how to use a detailer after detailer extension to improve faces automatically. Moreover, Rampot is also using Unix. It is also a cloud service provider, so it also has similarities to Kaggle training. And in this video I have shown how to sort generated images with the similarity to the training image that you provide. It is really helpful. I will show that. And there are 765 styles that you can use in Automatic 1111 Web UI. I will also show you how to use them. Very carefully following this tutorial video is really important because there are a lot of tricks that you need to do to make it work on Kaggle. All because of the limited RAM that Kaggle provides us. The Kaggle is only providing 13 GB RAM And this is same with Google Colab as well. These are free options. Of course, you can upgrade your account and get better resources both on Kaggle and also Google Colab. But for this to work on a free account, there are several tricks that we need to do. So follow this tutorial very carefully. The installation has been completed. How do we know? You see setup finished. So it says that the setup has been finished. Now before starting the Kohya GUI web instance, I am going to download and extract regularization classification images. I am using ground truth regularization classification images to improve the quality of the training and also prevent overtraining of the model. I have spent like 2 days to prepare man dataset and also women dataset. I have collected over 30,000 images from unsplash.com. Then I have pre-processed them with AI tools. Then I have handpicked each one of them to ensure every one of them is highest quality. Let me show you one of the example images. You see the details. This is an original image that I use as a classification regularization images. Then I have pre-processed all of them with the latest cropping and resizing script that I have coded myself. Let me show you the results. So all of these dimensions are available on my Patreon post. Just resize them into these dimensions is taking over 1 day. So this is a huge task that I have made. Let me show you some of the final images. In this tutorial, we are going to use 1024 to 1024. So these are all the face focused 1024 resized images. Let me show you one of them like this. You see, super high quality. Let me show you another one. You see, super high quality. I am not using the STXL generated images as classification regularization images because using ground truth images is better. However, if you are going to use stylized images that you like as a style of the base model, you can generate classification images from the base model itself too. So when we execute this line, it will download images and also extract them. Let me see if there is another error. Yeah, okay, there is no another error. So I just clicked this line and it started downloading, and then it will extract images into our working directory, Kaggle working directory. We will see that after extraction has been completed, it will also delete the zip file. This is automatically coming with the attached Patreon post. However, when you open this link, you will see I have all of the images and their links shared here, so you can download any specific resolution. You need to use the same resolution of your training images. So if your training images are 1024 to 1280, you need to use that. Or if they are 1280 to 1536, you need to use them. These are not just resized images, these are face focused resized images. Hopefully I will make a new video about my new scripts that I use it, and I will share them with you as well. Let's say you are not my Patreon supporter and you want to use your own classification images. To do that, we will use this upload icon here. Click this. You need to set a new dataset. This will be private by default. You see, no one else will have access to it. Let's say class images. You can give any name. Then click browse files. Select the files that you want to use as classification images. So I will select some of them from here to show you as an example. So let's say these are my classification images. Click open. They will get uploaded. You also need to give a name like class images. You see they are getting uploaded one by one. So you need to upload all of the files, then create. And after that, you will be able to use this dataset not only in this training, but also in your other trainings as well. How? Click this add data and your dataset will appear here. You see class images, just click this icon and it will be added into your training or into your session. You see like this. Now I can give the path of this folder and I can use all of the images. This is also the way that we are going to use to upload our training images as well. Normally this is so fast, but this time this is really slow. I don't know. So this upload feature is really important. This is the way to upload data into your Kaggle notebook. The advantage of Kaggle is that this data is permanently saved, so you don't need to upload again and again. When you start a new session, just click Add Data, select your datasets, find your dataset from here and click plus icon, and it will be added into your current runtime. This feature is not existing on Google Colab. Maybe you can use Google Drive and import files, but this is much more easier, much more convenient. So you just one time upload and you can use it later again and again. Alright, the classification images are ready. We can see them here. When I click this icon, it will expand it. There are over 4,000 files, so it is a little bit hard to open. When I double click this file, it should open. It's somewhere here. Okay, it didn't display. Maybe I can download here. I can click these three dots and click download. It is downloaded. Yes, you are seeing one of the regularization images. It is ready. This is also for human dataset. By default, I have added 1024 to 1024. If you need other resolutions, just go to the Patreon post and copy the link and replace it. After that, we are ready. What we are going to do is we will start the GUI instance with this command. This is the thing that we are going to run after the installation has been completed. As in other notebooks that run on cloud, we can execute one cell at a time. So if another cell is working, you won't be able to execute another cell. That is why I have executed this cell before I started the GUI instance. So I made sure that everything is ready. Okay, after you run this code, it will give you this public Gradio link. This is the link that you are going to use. You see it shows our available GPU here, the CUDA version, and the number of cores that it has. So click this Gradio link and it will open the Kohya GUI interface for us. Alright, now I will set up everything quickly. If you want to learn more about these settings, I suggest you to watch this amazing tutorial where I have explained a lot of things in details. So we go to the LoRa tab. Let's begin with configuration saving. So it will be saved inside Kaggle working test1.json. Click save. And we should see that file has appeared in our working directory. So I just expand it. Let's close this. Let's refresh by clicking here. You see test1.json file has been generated. You can go here, more actions, and you can download and look at it. Okay, source model. We are going to use custom. And in here, we are going to use the model shared on Hugging Face. We are not going to use save tensors file because it is using more RAM at the moment. However, I have opened an issue thread on Kohya GitHub repository and they have made a new commit. Hopefully it will use lesser RAM in future. So we need to copy this. This link is also shared in this file in here. You see repo name, and we just paste it into here, pre-trained model name or path. We are going to use Stable Diffusion XL base 1.0 model. You can also use Kaggle and Kohya to train SD 1.5 based models as well. Just use the settings for SD 1.5 version. In this amazing tutorial, I have shown how to do Kohya LoRa training on SD 1.5 based versions. So you can watch this tutorial to learn more about SD 1.5 based versions training. Select this checkbox. This is really important, SDXL model. After you make every change, just click save. Then we go to the dataset preparation. Now they moved this tab to here, which makes a lot of sense. So we are going to use OHWX rare token. There is also another approach using existing tokens to train yourself, such as celebrity names. Hopefully I will also explore that option and make a comparison video, so we will see which one is performing better. Rare token approach is still working. We are going to use man class if you are woman, woman class. If you are training something else, just that class. Training images folder. Now this is important, how you are going to give the path of the folder. First we need to upload our training images, so I click this icon, upload, let's say training images as the dataset name. Let's make it the dataset title as well. Click browse files. My images are inside pictures, inside me new size, inside here. You see, I am using 13 images. These are not the best quality training images. Hopefully, I will make another tutorial about what kind of images are good quality images for training. So I click open, they will get uploaded. You see, it says this file already exists in my dataset. So once this is done, you just do the upload and it will start working. Currently, it wants me to use my existing dataset. So how am I going to do that? I am going to do that with add data, your dataset, and my images are here, my test dataset. I click plus icon and they will get added here. You see now added, copy file path and paste it here. Now we are ready. I am going to use 25 repeating. So for every training image, it will use 25 different classification images, regularization images, both classification and regularization images meaning same thing. So my regularization images are here. Copy the directory path, paste it here. We are using repeating one where I want the trained models and output to be saved. So I copy this and I say results. So this will be the folder where the trained LoRa checkpoints will be saved. So now what I need to do is first click prepare training data and watch the messages. You will see here carefully. We should see the copy option here. So you see it says done creating folder. So it copied all of the files both here and also here into our new folder. You see results. And you see my output is now using more. After this operation has been completed, you can delete the classification images folder here to open more space. However, to delete it, we need to stop this running GUI. I will do that later. So after this operation, I click copy info to folder stop. And when I go to folders, now you see all of the folder paths are copied correctly. You have to have exact folder naming structure for Kohya to work. So use this dataset preparation. And what name I want for my LoRa's, I will name them as Kaggle test 1. And then I click save. Now time to set parameters. So I am going to use standard LoRa. There could be better options, but this is what I have found. We are not going to use cache latents at the moment because they are causing out of RAM error. Hopefully it will get fixed in future updates. I made a discussion about this with the developers and they are going to implement a fix. We are going to use mixed precision as FP16 and save precision as FP16 because the free GPU the Kaggle provides is not supporting BF16. We are going to use Adafactor as optimizer. I'm going to use constant learning rate. Okay, optimizer extra arguments. This is important. We are going to use these extra optimizer arguments. So copy them from the GitHub file. This is also shared in this Kaggle notebook as well. You see here. So I copy paste it. I'm going to use learning rate as 0.004. Let me zoom in so you can see better. So this is the learning rate that I'm going to use. The learning warm-up steps doesn't matter because we are using constant. Max resolution. This is really important for STXL. We are going to use 1024 to 1024. Don't forget that. I am not using buckets, so I suggest you also to use single bucket. Make all of your images same resolution. Otherwise, you may get out of VRAM error. Text encoder learning rate same as the learning rate. Unit learning rate same as the learning rate. Network rank dimension. Now I am going to use 32. However, 64 may also work on Kaggle. But as you increase your network rank dimension, there is a trade-off. The trade-off is, let me show you, when you go to the GitHub README file and when you open this Twitter post, you will see a comparison image here. By the way, this is my account, so you can follow me on Twitter. I am sharing a lot of useful information. When you look at this picture carefully, you will notice that the trees at the background in the upper image has less details when compared to the trees at the below image. The above image has 256 network rank dimension. The below image has 32 network rank dimension. 256 network rank dimension, providing more details about the subject. However, the model itself is forgetting some of the information it has. So there is a trade-off between higher network rank dimension and lower network rank dimension. 32, 64, even 96. You can try with different network rank dimensions and see which one is working best for you. But 32 is working very decent. Network alpha is 1. Let's save the settings. Let's go to the advanced tab. Now there are several other important settings that we need to set here. First of all, gradient checkpointing. We need this. This is slowing down the training. However, this is extremely reducing the VRAM usage. We are also going to provide additional parameters, which is --low RAM, which is shared here and also shared in the GitHub file. Here, low RAM, don't forget that this is necessary to make it work on Kaggle. So gradient checkpointing, low RAM, and nothing else we need. In future, you can also select full FP16 training. This will also further reduce VRAM usage, but it doesn't make difference at the moment as far as I have experimented. So let's click save. But we are not going to click start training because Gradio instance is also using RAM and we need every bit of RAM. So what we are going to do is print training command. Go back to your Kaggle here. You need to do this once everything is set. So it shows train batch size 1, max train steps 650. I noticed it my error, which is the number of epochs. So currently it is going to do training for only one epoch. However, I find that 200 epochs total training is good for training a person. Since our repeating count is 25, when I do 8 epoch, it will be total 200 epochs. I explain all of this in the other videos that I have linked. So number of epochs is 8. Save every and epoch is 1. Let's save and click print training command. And let's get the command one more time. So select this, Ctrl C and copy it. Open a new notepad file, paste it, and check out the command that you are seeing. This is my command at the moment. I am verifying everything. It is going to do 5200 steps. Why? Let me calculate it for you quickly. So I have 13 images. I am doing 25 repetition at every epoch. I am going to train up to 8 epochs. And I have classification regularization images. So it doubles the number of steps, number of training. So I have 5200 steps. Everything is looking correct. So I have copied this. And after that, I need to stop this running cell. Let's clear everything. So I right click somewhere and I click clear outputs or clear all outputs. Everything is cleared. Let's delete the classification images directory so we will have more space. Let's click this. We can delete this. Why? Because we already copied all of the images into results folder here. So when we refresh it, it will get refreshed soon. After that, we are going to execute command from here. So put an exclamation mark to the beginning, paste the command that you have copied and click this cell. This cell will start training. You see my currently used hard drive space is also reduced to 2.7 gigabyte. This process will take a lot of time. For 5200 steps, it is going to take like 7 hours. But since this is free, this is better than nothing. If you don't have a GPU, if you don't want to pay the paid cloud services, you can use this. Just start it and left it open. It gives you 30 hours per week, which is amazing. So it is going to download necessary model files. You will see all of the messages are being printed here. Image count 13, number of repeats 25. These are really important. Verify them. You see this is the folder name. Use OHWX as a rare token. Don't use some random tokens or use some existing celebrity name token. That is another approach. I am not using it yet. I am not using captioning. Hopefully I will also explore the captioning effect in future. So stay subscribed. This is the number of classification regularization images it has found. But it is not going to use all of them. It is only going to use number of repeating multiplied with image count. So how many regularization classification images I need? I need 13 multiplied with 25, 325. This is the number of images I need. if I have made number of repeating more, or if I had more images for training, I would need more classification regularization images. So here it is showing 338 total images. Why? Because 325 classification images plus number of training images is equal to this. Okay, it is showing the more messages. It is downloading the STXL files from the Hugging Face. We are going to use diffuser files, not the safe tensor file, because this uses lesser RAM. So it has downloaded all of the files. Now it is converting unit. You can also watch the progress here. You see this much RAM is being used. This is the GPU RAM, first GPU, second GPU. We are going to fully use all of the RAM of the both GPUs. In free Google Colab, it is not working because free Google Colab is only providing one GPU and same amount of RAM. Therefore, we are getting out of RAM there. I have tested a lot of times on Google Colab, but all failed. I couldn't make it work. For making Kaggle work, I spent like 2 days, a lot of research, a lot of experimentation and testing, and this is the best way of making it work on Kaggle with also doing text encoder training. If you only do unit training, it would use lesser VRAM. However, for rare token approach to work, you need also text encoder training. Also, let's say you are doing a style training or other trainings, you would need a rare token approach in many cases. You see, we are using dimension rank 32. Okay, and the training started. Let's see the speed. So it starts with 9.19 seconds IT. It is going to get down about 5 seconds per IT. In total, it is going to take like 7 hours. Currently, it says 10 hours, but it will get decreased over time as it gets more normalized. So it has been over 90 minutes and we have 4 epochs so far. However, the number of epochs it is displaying is doubled. I think this is because it is doing training on dual GPU. That is why it is displaying as double epochs, but the total number of steps, the number of training is equal as it is supposed to be. So this is equal to 8 epoch, 25 repeating and 13 training images with classification images. I asked this on Kohya to verify whether this is because of dual GPU or it is another bug, but I am pretty confident that this is because there are 2 GPUs right now being used. So our LoRa checkpoints are saved inside our output folder inside results. You see, after I click it here, it is expanding the folder. When I go to model and wait a little bit, I will see the saved checkpoints and how you can download them. When you hover your mouse like this and go to the 3 dots at the right, you will see download option. Just click them and download them. This is the way of downloading them. However, it won't show you the progress of download. When you open your task manager and when you open your Ethernet, you will see the download is happening. You see it is downloading with 100 megabits per second, which is my interconnection speed. So it is super fast when compared to Google Colab. And once the download has been completed, you will see immediately the files are downloaded. Let's wait a little bit. We should see in a moment. Each safe tensor file is currently 228 megabytes because our network rank dimension is 32. If you go with lesser rank, it will be lesser space. So 16 rank would be 114 megabytes. Or 64 rank would be like 450 megabytes. Okay, files are getting downloaded as you are seeing right now. So you can watch your download progress from here and the other file download has begun. However, if you want to download entire folder, this is the command that you need. This command will zip them and you will be able to download all of them. I won't wait until this training is completed because I already done the same training with exact same parameters. So for now, I will just stop the training and download all of them as a zip file. Let's clear all of the outputs. Let's stop the ongoing progress. You have to stop it or wait it to be finished to be able to execute this command to zip all of the model files. So let's expand the results folder one more time. Okay, maybe we need to refresh. Okay, Sometimes you may get this warning message. Just wait patiently. Okay, now I will execute this command. This command will make loras.tar.js file in the working directory. This may take a while. Just wait until this is completely executed and finish it. By the way, you need to have sufficient output space to execute this zip file command. You see the output space that I am using is getting increased. Okay, the execution has been completed. Now I see the loras.tar.js file. Click here, download. So how you can open this? You can open it with WinRAR. Just type WinRAR to Google and download from rarlab.com. This is the WinRAR download site. Just go to downloads and download it. If you can't extract the downloaded file, it is not displaying the download status, but from the task manager I can see it is downloading. To be able to follow this tutorial, you don't even need a computer. You can do this tutorial from your iPad, your iPhone, your Android phone, your Mac, wherever you are able to use a browser, and you can upload images and you can type text. So it is not limited to computer. You can follow this tutorial anywhere. You see currently it is downloading with full speed of my internet connection. Once the download has been completed, I will see the download happening from here. Also, when you try to download multiple files, the browser may ask you that this site is requesting to download multiple files. You see, continue allowing automatic downloads of multiple files. Just make sure that you have allowed it, otherwise you won't get downloads completed. So that all of the downloads were completed. When I open this download, I can see inside of it by double clicking, and I can extract them and start using them. So I will show you how you can use them on your computer with Automatic 1111 Web UI. Hopefully I will make another tutorial for how to use Automatic 1111 Web UI on a free Kaggle notebook. It will be perhaps the next tutorial, so stay subscribed. And let's say you want to keep your LoRa's on a Kaggle dataset that you want to use later. So how you can do that? Let's extract LoRa's into LoRa's2 folder like this. So they are getting extracted into this folder. Click this upload icon. Let's say my LoRa's. Let's give the same name, browse files. Open the folder, select the LoRa Safe Tensors files, open them. They will get uploaded into here. They will be private unless you make them public. So this is the way of uploading and permanently saving files in your account. However, you have space like 100 gigabytes, but it is really sufficient. And once the uploads are completed, just click create icon. So for now, I will just terminate my session because I have shown everything. Now time to use these LoRa's on our Automatic 1111 Web UI. So to terminate your session, click here and it will turn off your session, and everything in this output folder will get deleted permanently. I have explained everything from scratch, how to install and use Automatic 1111 Web UI with LoRa's in this tutorial video. So watch it if you don't know how to use Automatic 1111 Web UI with LoRa's. Let me show you the LoRa files from my last Kaggle training before I have recorded this video. They are inside models, inside LoRa folder. You see these are all the LoRa's I trained on a free Kaggle account, starting from 1 to 15, and the last checkpoint will not have numbering like this. So this is actually number 16. Let's fix it like this. Okay, number 16. These LoRa's have 200 megabyte size because they are network rank dimension 32. If we go with network rank dimension 256, they will become like 1.7 gigabytes per checkpoint. So how we are going to use it? I will just start my Automatic 1111 Web UI. And one another thing I want to mention is I have styles.csv file. When I open it with Notepad++, these are all the styles where you can download them. You can download them in this GitHub README file. Click the styles.txt file. After download has been completed, open your downloads folder, rename it to .csv file extension like this. So let me sort it. You see, styles.csv file, and paste it into your main automatic web UI folder. Restart your web UI. They will appear in your styles tab. Now I will show you that the instance has started. So the styles are here. You see all of the styles from that styles.txt are here. So how you can test and find the best checkpoint, I have explained it, finding the best checkpoint of LoRa's in this tutorial, so please watch it. Yesterday I have found my best checkpoint and I have generated over 3000 images. The generated images are all here. Let me show you them. So these are the images that I have generated over 3000. Let's open one of them. So I drag and drop into PNG info like this, and when I send text to image tab, I will see all of the details. So I use the checkpoint 10. It could be different for you based on the training images that you have. So how did I decide this? I used XYZ checkpoint comparison. Let me show you the output of XYZ checkpoint comparison. So it is inside outputs folder, inside text to image grids. Let's go to the yesterday and let's open the final grid file. And this is the final grid file. It's a pretty big file. So I have analyzed this file and look at the each checkpoint, and I decided then the checkpoint 10 is the decent one, the sweet one. So this may change according to everyone cases differently. You need to find your best checkpoint. As I said, watch this tutorial to learn how to do XYZ checkpoint comparison. Alright, so how you can use your trained LoRa. Since we have done training with OHWXman, this is my main prompt that I have to use. So I am going to use cinematic style as I have used it yesterday. I select cinematic style. I set the resolution 1024 to 1024. Use the same resolution that you have used it for training. This is really important and crucial. You shouldn't use 512. Select the correct VAE file. If you select SD 1.5 version VAE, you will get very problematic output. So either select correct VAE, SDXL VAE, or none. If you had set previously your VAE from Stable Diffusion VAE in here, then it could be using the SD 1.5 version VAE. So make sure that you have selected correct VAE. I explained all of this in the previous video. Now time to select our LoRa. Currently the interface is here, but it will be moved to here for selecting LoRa. When you are watching, it could be already published. So I click here. In the new version of Automatic 1111 Web UI, you will see the interface like this. So click LoRa. Find the LoRa that you have done your training. So my LoRa is at the very bottom. You see test Kaggle. So I'm going to use test Kaggle 10 like this. Let's close the LoRa interface. In the neighbor interface, you will click here for text to image tab to return back. And I need nothing else. Currently, after detailer extension is not enabled. What does this extension do? This extension masks automatically the face and inpaint it with the prompt you use it here or with the prompt you define here. It is totally optional. So let's generate 12 images and then let's regenerate them with after detailer extension. So let's hit generate. Since this style is applied, you will see the executed prompts here. Currently it doesn't show because we are doing batch, but after batch we will see it. So the very important part of using LoRa is appending the LoRa name into your prompt like this. Don't forget that. This is the most crucial part. So here are results. When I click one of the images, I will see the fully executed prompt. So the style prompt is added like this. Cinematic film still OHWXman. This is our rear token and class token. This is our LoRa prompt and the rest of the style. And there is the negative prompt that is coming from style and the other settings. So these are the base images generated. Now let's also apply after detailer and compare it to have same batch. I will use the last seed. So I click here, it will use the last seed. This should be the seed of the first. So seed is here, and here you see. When you do a batch, it increases seed by 1. So it will be same. You see when I click, the seed is increased by 1. Alright, let's generate with enabling after detailer and compare the results. So this was the first results without after detailer, and we will see the effect of after detailer. You can install the after detailer from extensions. It is just very easy to install. Go to available, load from, find the after detailer from here. It is in the installer tab, so I need to uncheck this, and after detailer is here. So you need to find this, install and restart, then you will have this extension. Alright, it is almost done. Okay, after detailer results has arrived, now time to compare them. So I copy, paste into paint.net, and now we can have a comparison. Okay, let's see. Do we have much improvement? Perhaps we need to compare one by one. Yeah, there is a slight improvement in the images. Still, you may not get your best results. Okay, let's, for example, look at this one. This is after detailer, not very much like me, but face is decent. And this is without after detailer. You see how dramatic effect the after detailer has in a distant shot. To have beautiful images even in distant shots, you need higher resolution training. Not even 1024 to 1024. You need like 1218 to 1536 to have good faces in distant shots. So after detailer will make your job easier to get more quality images. So how you can get very alike images with your training with easiness? Stable diffusion is the numbers game. So what you need to do is generate a lot of images like you are seeing here, over 3000 images, then find the best looking ones. However, it is extremely time consuming to find the best ones by looking all of the images. So what else you can do? I have an amazing script that I have developed myself by using DeepFace AI. This script will sort all of the images based on a reference image. So I give this image as a base image. Based on this real training image, the AI will sort images by similarity to this image. So let's see the similarity sorted images which are here. When you look at the file names, you will see the distance, which means the similarity between the base image and this AI image. If the distance is smaller, the image is more similar to your base image. So from these images, you can easily find the very best looking images like this. You see, it is very similar. It is super high quality. Yes, of course, we are losing some details. It is because of the resolution of training. Perhaps with high resolution fix, we could get better images. I didn't do much testing, but you see the similarity is very canny, very good. Or let's look at another image. These are cinematic style prompts, and they are really looking decent. Let's look another one. For example, this one. You see, with this way, you can very easily sort images and find the best looking ones. I will also look for different workflows to even obtain better, higher quality results. I am in search. Hopefully, I will experiment with using celebrity token strategy. I will also do full Dreamboot training, and I believe I will get even better results. But for now, this workflow is working very decent. You can also use this workflow for style teaching or for other objects teaching, whatever you want. So stay subscribed for this. This is all for today. I hope you have enjoyed. Please go to Stable Diffusion tab from here, start our repository, fork it and watch it. Also, if you become sponsor of me, I would appreciate that very much. You can also support me on Patreon. You can buy me a coffee. You can follow me on Medium. You can follow me on Sweet AI. You can follow me on DeviantArt. You can also subscribe our channel. You can also follow me on LinkedIn. This is my Udemy Stable Diffusion course with over 100 students. Let me open it and show you. You see we have over 133 students with 4 8.8 stars. I hope you also consider to purchase my course here and support me. And you can also follow me on Twitter. I am sharing a lot of useful information on Twitter, so please also follow me here as well. Hopefully see you in another amazing tutorial. See you later.